Welcome. In this video lecture, I am going to talk about how we can solve the dynamic lot sizing problem using Wagner-Whitin algorithm. Wagner-Whitin algorithm is basically based on the dynamic programming approach, which is basically the optimization approach, or we can say from the operations research technique. As the dynamic programming is a recursive algorithm, so same as the Wagner-Whitin, because it is based on the dynamic programming, it uses this recursive algorithm to solve the problem. So how this Wagner-Whittle algorithm works? So it will start solving one period problem and then continually moving towards the next time period of the planning horizon, and it will continuously solving multiple planning horizon problem until the defined planning horizon is solved. Like for example, if I am saying that we have a 3 time period planning horizon, so what the Wagner-Whitten algorithm is going to do, first it is going to solve for the time period 1, planning horizon, solve the problem. Then in the next, we are going to solve the for the iteration number 2, that is we are going to solve for the 2 planning horizons problem. Then we are going to solve the third planning horizon, and then we are going to compare the total cost of the dynamic lot sizing problem under which we are getting the minimum cost, whether against the planning horizon number 1 or a 2 or a 3. So basically, the ultimate idea behind the dynamic programming is we are going to divide the larger problem into the smaller problem, and we solve those smaller problem in order to get the optimum solution. So what's the Wagner-Whitten property while solving the dynamic lot sizing problem is that either the inventory we are carrying from T plus 1 from the previous period will be 0, or either the production quantity, or you can say the order quantity, will be the 0. Okay, so let's learn this dynamic Wagner-Whittle algorithm with the help of an example. So I am considering that this particular problem. So we have the month that is from January to June. So every month that is the demand is given, which is 36, 60 up to 75. And whenever we are going to place the order, the ordering cost is $80 that is given, and the carrying cost per unit is $1.75, right? So first of all, in a first iteration, what we are going to do is, as we have seen that the Wagner-Whitten is going to solve the entire problem for time period wise, which means breaking down the entire planning horizon into one period and then two and then three, right? So in a first iteration, first of all, the planning horizon is 1, which is indicating that we are going to meet the demand of January by ordering at the start of the January exactly equal to the 36. So based on that, we are going to calculate the total cost. So first of all, the total cost, we know that that is going to be the sum of the ordering and the carrying cost. So the order cost at the start of the January, which is $80, and the carrying cost, which is basically the average carrying cost, we are going to calculate with the help of this formula, which we have already discussed in detail while we were talking about the silver meal heuristic, okay, in our previous video lecture. So how this formula is we have developed, which is basically calculating the average inventory. So per unit carrying cost, and this is the average inventory of a defined planning horizon which we are considering right now. The planning horizon we are considering is 1. So that means the capital T is equal to 1. So we will get 2 into T is equal to 1 minus 1 divided by 2 into D1, right? So basically what we are getting 1.75 is the carrying cost or the holding cost multiplied with the average inventory. So this is the carrying cost. So holding cost plus carrying cost is the total cost against the planning horizon 1 we are considering. No, in the iteration 2, what we are going to do is we are going to consider the planning horizon for the period 2, right? That is this one. So if we are saying that how we can meet the demand of the January and February, there is a two options we have. The option number one is, that is, we should order the quantity at the start of the January, or we should produce the quantity at the start of the January equal to the demand of January as well as the February. And the second option is that we should produce or the order the quantity at the start of the January only for the January, and then at the start of the February we should produce equal to the demand of the February. So option number one is that we are placing the order at the start of the January to meet the demand of February, and then option number two is, that is the optimum total cost in the iteration number one, that TC1 is representing this one. Okay, and then we are placing the order at the start of the February, and TC1 is basically representing that that we are meeting the demand of the January in the month of the January, and the total cost we have incurred, that is this one, plus we are placing the order at the start of the February in order to meet the demand of February. So against these two options we are going to calculate the total cost. So against the first option, when the planning horizon is 2, which means we are placing the order or we are producing the quantity at the start of the January in order to meet the demand of January and February. So the order cost is going to be 80, and the carrying cost for the planning horizon 2 is, that is the per unit carrying cost multiplied by the average inventory for the planning horizon 2, which is 189. So 80 plus 189 is going to be 269, right? That is if we are going to place or produce the quantity at the start of the January. Now, in option number two, first of all, we are calculating the cost in the month of February, because we have already calculated the total cost in the month of January, which is equal to this one. So in order to calculate the total cost in the month of February, so that is the order cost, which is basically we are placing the order in the start of the February. Okay, and then we have the holding cost, then we have the average inventory of the month February, which is this one. So TC1, that is basically the optimum total cost in the iteration number one, plus the month of February total cost. Okay, so against option number one, the total cost is 269. Against the option number two, the total cost is 244. Okay, which is basically TC1 plus this 80 plus this one, right? So till iteration number two, but we are got the decision because we have solved the problem till February. So till now we got the answer because the option number two is good one. The smaller, having the smaller total cost. So that means we should order at the start of the January equal to the demand of the January. Okay, and then we should place the order at the start of the February equal to the demand of the February in order to meet the demand of January and February. Now we are performing iteration number three. So in iteration number three is basically we are considering the planning horizon up to 3, which means starting from January to March, right? So in order to meet this demand in the iteration number 3 is we have three options. So either, which mean we need to check three options, which mean the first one is if we are going to place the order at the start of the January, we should place the order equal to the sum of January, February, and March. The second option is, according to the Wagner-Whitin, is that we have the optimum cost of the January, which is this one. Okay, and we should place the order at the start of the February in order to meet the demand of February and March. Okay, and the third option is we have the optimum cost of the January, we have the optimum cost against the February. Okay, and we should place the order at the start of the March in order to meet the demand of March. So we have three options. So against every option we need to calculate the total cost. So against the first month, which means January, if we are going to place the order in the month of January in order to meet the demand of January to March, so that means we have one time order cost, and the carrying cost is going to be the average inventory in January, the average inventory in February and March. Okay, so that is going to be calculated using the same particular formula. So this is basically the total carrying cost if we are going to place the order at the start of the January. So the total cost is 80 plus this one, that is this one. So which means at the start of the January, we are placing the order equal to the demand of January, February, and March. So the total cost is going to be this one. The second option is that is TC1, which is the optimum cost uh, in order to meet the demand of the January. So that means we decided that in order to meet the demand, we should place the order at the start of the January. So now we have to decide from the February to March, right? So that means we are going to place the order at the start of the February to meet the demand of February and March, as well as we have already decided that in order to meet the demand of January, we should place the order at the start of the January. Against that, we have already calculated the total cost TC1, which is basically this one. So in order to calculate the total cost at the start of the February to meet the demand of February and March, so we have the order cost at the start of the February, and then the carrying cost for the February and March is going to be this one. Okay, if we sum up this one, that is going to be this one by adding 111.5. So we got this one, right? And then we have option number 3. So option number 3, that is basically indicating the T2 is basically the optimum cost, which means in a iteration number 2, what is the smallest cost we have? That is this one, which is 244. Okay, so that is T2 is basically indicating the total cost until the demand of February we have met, right? So that means we only need to decide we should place the order at the start of the March in order to meet the demand of March. So we have, when we are placing the order at the start of March, 80. So this is the carrying cost, which is against the average inventory, and this is the total cost. This is TC2, and this is the total cost in the month of March, which is this one. So again, if we are going to compare the total cost against all options, so option number 1, option number 2, option number 3. So option number 3's total cost is smallest one. So that is basically indicating that in order to meet the demand of January and February and March, so we should place the order every month separately. So in order to meet the demand of January, we should place the order at the start of January. In order to meet the demand of February, we should place the order at the start of February. In order to meet the demand of March, we should place the order at the start of the March. Now, according to Wagner-Whitin algorithm, because we are talking about from January to June, now I'm considering the problem with respect to till April. Okay, so that means from January to April, right? So if I'm considering from January to April, so that means we have 4 options. Option number 1 is in order to meet the demand from Jan to April, right? So option number 1 is we should place the order at the start of the January in order to meet the demand of January to April. Option number 2 is that is the TC1, that is basically the optimum cost to meet the demand of January. Okay, so that means we are placing the order at the start of the February to meet the demand of February to April. Then option number 3 is TC2. That is basically till the February we got the optimum cost, and then from March to April we need to decide. So in order to meet the demand of March and April, we should place the order at the start of the March. Okay, and the fourth option is till the March we have got the total cost. Okay, which is in the iteration number 3 the smallest cost, okay, or you can say the optimum cost, and then we should place the order at the start of the April to meet the demand of April. So let's calculate the total cost against all 3 options. So option number 1 is if we are going to place the order at the start of the January to meet the demand of January to April, so the total cost is going to be ordering cost. This is going to be the average carrying cost, and the total cost is 80 plus 628.25 against the option number 2. That is basically the January's, which means the iterations one's optimum total cost plus ordering cost and carrying cost. So that is 80 plus this one, right? So this was 111 point something, which is 25, I believe. This is 80. This is 323.25. 0.75, right? And then option number three is, that is we have the decided till the February, which means we have the optimum total cost or till February, right? We not need to decide from March to April. So for the 2 months, the ordering cost at the start of the March and the average carrying cost for the March and April. Okay, so that is going to be the total cost for the option number three. For option number four, so that means we got the decision till the March, that is the optimum cost till the March, and then for the April, for only 1 month, we are going to calculate the total cost. This is order cost, this is carrying cost, and this is going to be the total cost. Okay, so now let's compare all three options total cost. So against option one, when we are placing the order at the start of the January to place the demand from January to April, we have option number two when we are saying the optimum cost of iteration one, which means the optimum cost to meet the demand of January, that was this one, and this is the total cost from February to April. This was the total cost for January as well as the February, and now this is basically the total cost for the March and April, that is this one. This is the total cost till the March, which means January, February, and March, and that is we have decided till in the iteration number three. Okay, and this is the total cost of for the month of April, that is this one. So if we are going to compare all three options, so we can see that option number three is the best one, which means the total cost, minimum total cost against option number three is the best one. So how we are going to read this one? So TC2, which means iteration number two, and in iteration number two, we have already decided, that is, so we are going to in iteration number two. So we have already decided that we should place the order to meet the demand of January and February separately. So which means in order to meet the demand of January, we should place the order at the start of the January, as well as in order to meet the demand of February, we should place the order at the start of February. Whereas because the option number three is the best one in iteration number four, whereas in order to meet the demand of March and April, we should place the order at the start of the March equal to the demand of March and April. Okay, so the total cost is going to be minimized. So till iteration number four, we have taken the decision till April. Similarly, we are going to perform the iteration number four. Now we are considering till May. So January to May. So we have five options. So option number one is we should place the order at the start of the January to meet the demand of January and May, January to May. Option number two is we are taking the best optimum solution to meet the demand of January, and then we should place the order at the start of February till to meet the demand of February to May. Option number three is we should take the minimum or the optimum cost to meet the demand for January as well as February, which means till February, and then we should place the order at the start of March to meet the demand of March to May. Option number four is, that is we should take the optimum cost till the meet of demand of March, and then we should place the order at the start of April to meet the demand of April and May, as well as the fifth option is we should take the total cost till the meet of demand of April, and then we should place the order at the start of May. So we have calculated the total cost using the same approach for all five options, and we can see that this is the minimum total cost. So what's that mean? So in iteration number four, we have decided that, that is TC4, this one. So in iteration number four, so which is TC4, we have already decided that to meet the demand of January and February, we are going to place the order separately in every month. But in order to meet the demand of March and April, we should place the order at the start of March. For in iteration, for in order to meet the demand of May, so we should place the order at the start of the May. Okay, so that is iteration number five is telling us. Similarly, if I am going to consider iteration number six, so again we have the sixth option, right? So I believe you got the idea how we are developing these six options. Again, I am comparing the total cost. So as you can see that the total cost is this one is the smallest one. So what we are concluding, so this is a summary form of the solution, that we should place the order at the start of the January 36, which is basically equal to the demand of January, and the total cost is going to be this one till the January month. Okay, for only the month of January. This is 60, basically that is indicating that we should place the order at the start of the February equal to 60 to meet the demand of February. So this is the total cost. In March, we should place the order equal to 96, which is basically the demand of March and April. Okay, and this is the total cost. And then at the start of May, we should place the order equal to 39. This is the total cost. And at the start of June, we should place the order equal to 75. This is the total cost. So if we sum it up, so against the entire planning horizon from January to June, the total cost is $687, right? Which is the best optimum cost according to the Wagner-Whitin algorithm. So in the previous video, we have solved this particular problem using the silver meal. So you can compare both the algorithms result, which algorithm is giving us the smallest cost. So